Gravimetric analysis is a method of quantitative chemical analysis, quantitative meaning measurements, usually of mass, in which the constituent sought is converted into a substance of known composition. As I go through this example, you'll see that we are looking for a component within an unknown that we then convert to a known composition. We then separate and weigh that substance. The steps commonly followed are first preparing a solution containing a known weight of the sample, separating the desired constituent or substance, weighing the isolated constituent, and then computing and calculating using that mass and the known substance to find the unknown constituent. The typical laboratory steps needed, this is the analysis of a sulfate ion concentration, but the steps are almost always the same. You first create a solution of the substance that you're wishing to analyze. You then precipitate the component that you're interested in. You filter that precipitate out. This is the known substance that you have made that contains your constituent. Then you must dry and weigh that new compound. Again, a gravimetric analysis to analyze the calcium ion concentration would involve first dissolving the calcium ion out of the substance that it is in and then precipitating it. We must make sure that we form an insoluble calcium precipitate. We would then wash and filter that now known formula and dry and weigh. Once we've weighed the known calcium compound, we then can back calculate for the calcium concentration. Let's use an example. We've got an unknown sample that contains a lot of things, but what we're interested in is the calcium ions. The entire sample has a mass of 0.4367 grams. We would dissolve the sample in water to release the calcium ion. So we now have the calcium ion in solution. We would pick an anion that would form a very insoluble calcium compound, in this case the oxalate ion. So we form a known calcium oxalate compound. We know its formula. We then wash, filter, dry, and weigh the precipitate. The precipitate has a mass of 0.2920 grams. This would be the calcium oxalate monohydrate precipitate. From the grams of that known compound and its molar mass, we get the moles of the calcium oxalate that we have formed. We then use those moles to figure out the moles of the calcium ions in that precipitate. And finally, the grams of the calcium in that precipitate. Remember, the mass of a calcium ion, mass of calcium will be the same. The only difference is the electrons, and their mass is negligible. The mass percent of calcium in the original sample. We're not interested in the mass of calcium ions in the precipitate. That's already known. Those calcium ions came from the unknown. We put them in a known compound. We analyze the known compound and the mass of calcium ions in that compound. We then divide that mass by the original compound, and our unknown compound contained 18.34% calcium. The lab that you will be doing is analyzing an alloy that contains both silver and copper, and you will be analyzing it for its silver content. You will first take the alloy, weigh it. You will dissolve it in nitric acid. This will release the silver ions into solution. You will use the chloride ion, and you will use excess of it to make sure that you precipitate all of the silver ions into the known compound silver chloride, a very insoluble chloride. You will then filter, dry, and weigh the precipitate. And from that mass, you will figure out the percent silver in the original 0.2000 gram sample of alloy, not the percent silver in silver chloride.